Well, Liam, thank you very much for being with us again today. Well, I think everybody's very happy and excited to hear your presentation. I will switch a little bit in Spanish. Pues bueno, todos saben, ya Liam estuvo con nosotros el primer sábado. Él dio el kickoff de este diplomado y ahorita nos acompaña comentándonos un poco en el caso de Blockchain for the Future y cómo ellos desde San Francisco, Silicon Valley, uno de los ecosistemas más digitalizados, están utilizando este tipo de tecnologías. Y pues bueno, quiero que todos lo reciban. Please raise your hands. Por favor, levanten las manos para darle un aplauso y recibir a Liam. I just asked them, Liam, that they can raise their hands in order to applause for you, in order to receive you. And well, Liam, thank you very much for your time and welcome. This is your space.
Awesome. Yeah, thank you all for having me today. You know, it's been really awesome that you guys have, and thank you to, Fernando and Paulette for hosting me today and hosting this entire series. It's really awesome that we're able to take this content that we teach in English on a global basis to convert it to Spanish. And it's a lot of work that is taken to do that, to continue Blockchain at Berkeley's mission of teaching blockchain on a global mission. I know I'm speaking, many of you guys speak Spanish, or all of you guys speak Spanish, and English isn't necessarily your first language. So I've also added subtitles here. Hopefully that helps a little bit as well. But also feel free to ask questions in the chat throughout. And I'm happy to just kind of stop as we go. I'm not really a big fan of lecturing, and I like a lot more discussion-based conversations. And so as much as possible, I want to keep this as a discussion. So if you're just not understanding any concepts, feel free to just stop me, ask questions. I'll pause throughout as well for questions. And we can just kind of integrate questions throughout. And then at the end, I know we have 2 hours together. So then at the end, there'll also be an opportunity to ask personal questions. If you guys have any specific questions for myself or for me to talk a little bit more about my experience in the blockchain space. Well, to kick it off today, we're going to go, because we've thrown so much information at you guys over these last few weeks, we're going to do a little bit of recap on what you guys have learned so far, just to make sure that a lot of the really important concepts are ingrained in your head. And then we'll take it a step further by talking about the future, where, I personally see blockchain going, where Blockchain at Berkeley sees blockchain going, and more importantly, just where the blockchain space is going in general. A little bit about me before we dive in. My name is Liam. I'm one of the co-presidents of Blockchain at Berkeley. I previously worked on the business development and external sides of Blockchain at Berkeley. In addition to running Blockchain at Berkeley, I also help organize SF Blockchain Week, which is the largest blockchain conference on the West Coast. We have about 5,000 daily attendees at that conference. I formerly worked at Ripple, which is a blockchain company that we'll talk about a little bit later, really focusing on banking and how to restructure backend infrastructure for banking to make it easier to process and settle payments. And then I currently work as a software engineer at PayPal's blockchain research group. I study at UC Berkeley, and I study cannabis entrepreneurship at UC Berkeley. And when I'm not diving into the blockchain space, I really like to understand the cannabis space. And so that's kind of my focus of studies, is cannabis entrepreneurship. When I'm not focusing on blockchain, I also like to just kind of get outside and disconnect. So I'm a big backpacker, and then I also like the world of medicine. And so I'm also a licensed EMT. And I see a bunch of comments in the chat already. Awesome. I see that they're all in Spanish as well. So I'll leave it to Fernando for all the Spanish questions, but any questions that pop up in English, I'm happy to answer as we go along.
Thank you. just a quick announcement.
Yeah.
Si tienen alguna pregunta en español y no la escriben en inglés, escríbanla en español y yo se la digo a Liam en inglés, no se preocupen.
Awesome. And just, you know, before we dive in a little bit further, you know, what do you guys get out of this? At the end of the day, it's kind of what you want, as, you know, all these lectures, but I really encourage you to ask questions because that's where you're going to get the most out of this. So, you know, just making sure that you're understanding concepts as we go along is important. But then also as we look to the future and talk about use cases, I want to hear your guys' thoughts from what you've seen, or if you have any questions, or if you have questions that aren't even discussed in this deck, please feel free to bring them up at the end of the presentation. Before we dive into the actual content itself, I do just want to remind you guys a little bit about Blockchain at Berkeley. Blockchain at Berkeley is a university-based organization that's really focusing on driving innovation in the blockchain space. So we're really focusing on building this ecosystem that empowers students to make an impact through practical consulting for enterprise companies and blockchain startups, as well as conducting open source research and open source education. And so what we're really focusing on is just being this hub and this platform. You know, we want this platform to be somewhere, a building off point, so that you guys can learn from our experiences in the space over the last few years, as well as continue to grow in the space with us. To give you an idea of just how broad our organization is, we've got a whole lot of departments within ourselves, covering everything from, you know, the blockchain education. So this is our fundamentals content, but we also have a developer decal or developer course that we teach as well. And then we also have an edX course, which I'll talk about a little bit later on. Consulting, as I mentioned, we go from everything. We work with all sorts of companies, from enterprises to blockchain startups. We have our own accelerator, and then we also do open source research. And so diving in, a little bit of a summary of what you guys have learned so far. So much of this will sound familiar, but again, just making sure that these concepts are ingrained, because these concepts are really important to understand in order for you to be able to continue to advance your knowledge and your curriculum in the blockchain space. So we started off the lecture series talking about, you know, just what is blockchain and how does it compare to traditional, you know, peer-to-peer payment technologies. And so we can oftentimes compare this to Venmo, which makes it super easy for individuals to send, you know, small or large amounts to other individuals. And so, you know, Venmo is an example of a centralized peer-to-peer platform, whereas what we're trying to accomplish with blockchain is creating a decentralized peer-to-peer platform. And so you've heard a lot about these buzzwords: decentralization, anonymous, trustless, immutable, consensus, global. And, you know, what we really want to boil it down is the concept, so that you know more than just the buzzwords. And so we started off by talking a little bit about currency. And so we can compare Bitcoin with traditional banking transactions and currency systems, and analyze the different components of Bitcoin that make it a viable and usable currency. Because at the end of the day, Bitcoin has no central bank, no central entity controlling its supply or properties. So rather than relying on somebody like Chase or Santander or JP Morgan to handle all of your transactions and keep your money safe, Bitcoin actually allows for this decentralized ecosystem where you can guarantee that your money is safe within the ecosystem. You don't have to know all of your peers within the Bitcoin network to trust the math and economics behind it, which is what makes Bitcoin trustless. It's a protocol that allows you to distinguish malicious peers from honest peers. And since there's no point of failure, no one individual can alter the Bitcoin database. And so that's what makes it immutable. And then when we think about consensus algorithms, we've talked about how Bitcoin comes to consensus based on the people who are engaged in this network. And so it really is just a, you know, this continuous network that continues to build on one another. And as a consequence of all of these things, Bitcoin is global because it's not owned by any one individual or entity. It's not held by geographic barriers. And so that's what allows people to be able to interact with the blockchain network and Bitcoin network, regardless of which state or geographic location they're from. And so we talked about consensus and Sybil attacks. And so, you know, in this example, we've got Nadir, Jillian, and Brian, but then we've also got Gloria and Nick. But what we don't know is that Jillian is actually the person behind Gloria and Nick. And so in this case, Jillian is the one that has malicious activity. And so this is a barrier that, you know, the blockchain industry really struggled to overcome. But that's where these consensus algorithms come into play. And so when we talk about proof of work, we talk about how Jillian has these multiple identities, but limited resources. And so we want to focus on her ability to confirm transactions in this network, not based on the amount of identities she has, but rather the amount of resources she has behind her. And so, you know, what we're able to see is that with proof of work, we're actually able to verify that no malicious activity is happening because Jillian only has a finite amount of resources. And so those resources are being allocated, are just being distributed between Jillian, Gloria, and Nick. And so she doesn't actually have more power just because she has more identities, but rather she has the total sum power of all of the identities behind her. And so when we think about, you know, what were the motivations behind this movement, we can really point to the cypherpunk movement. And this was a movement of, you know, crypto anarchy, as some like to say. This ideology of Bitcoin stems from the cypherpunk movement, which is a libertarian fight for privacy and self-governance using cryptography. And so in the 1980s and 90s, the cypherpunk movement evolved out of libertarian ideologies of independence from a central point of control, most frequently being the government. And so that's why also you can see that the first transaction in the Bitcoin network was actually referencing the failure of large banks and corporations during the 2008 financial crisis. And so as we go even a little bit deeper into the structure of how these networks are composed, we can talk about how these block headers are created, how these block headers are what's actually defining the information within this blockchain. And so we can see here that this block header is made up of the previous block hash. So that way we're always pointing to the past and keeping track of where we came from in order to move to the future. It's keeping track of the nonce, and then it's keeping track of a Merkle root as well, which are details that we won't necessarily go into for these purposes. And so, you know, again, there's a lot of really deep concepts that we've already dove into. But the big thing to just kind of take away is that we're using public key cryptography to keep track of all of these identities and ensure that everything is staying safe and valid throughout this network. And when we talk about creating these actual transactions on the network, we think about mining. And so mining is the process of the validators in this network actually creating these blocks and confirming them to the Bitcoin network. And so the process for this mining involves downloading the entire blockchain, or Bitcoin blockchain, or any blockchain network out there, verifying the incoming transactions, creating these blocks, finding a valid nonce, which is a valid identifier for each block, and then broadcasting that block. So saying to all the peers in the network, hey, this is a block that we really believe is valid. We want to push it to the network, and then the profit comes from other validators or other miners in the network actually confirming, yes, this is a valid transaction in the network. And so diving in a little bit deeper, you know, what we're doing is we're actually getting these blocks from the peers. And so this is how we download the blockchain. And we start from the Genesis block, which is the first block in the blockchain. And so in the Bitcoin network, that's the block where it specifically talks about the failure of the big banks from 2008. And so this network is actually having to stay up to date the entire time and constantly fetch these new blocks in the network in order to make sure that it's able to make proper references for the future. Because the last thing we would want is for a miner to think that I still had $100 even after I sent 10 of that dollars to Fernando, and then be able to allow me to send that money, that $100 to another person. And so that's an attack that we often call a double spend attack, which you've probably learned about earlier in the series. And then that final step is, once we're creating these blocks and mining these blocks, is broadcasting it to be able to say, hey, I'm Janice. I just found a new block. Come check it out. And Satoshi is able to say, oh, dang, you beat me to it. And so Janice is able to get the rewards for that block. And so it's this spirit of competitiveness for every single block in order to make sure that all parties in the blockchain network are honest with each other. And so, we find that when there's a lot of transactions happening all the time, there can be a little bit of confusion as well. And so what's really important for this network is for every single peer in this network to be able to communicate with one another. And so as you can see here, you've got Rusty confirming that the block header is the one that he wants to work with. Justin is confirming that the mining reward is attached. And so that's making sure that he's profiting from it. Oscar's constantly communicating about and making sure that the transactions are actually valid in this network. And Satoshi is, just double checking all of the questions. And so what's really awesome about this network is this is distributed among thousands of peers globally. And so all of these parties in the network are constantly keeping this communication up to ensure that every block that's mined is absolute. And so here we go. We can see that, they're all confirming the validity of their transactions. And at the end of the day, the reason why mining works is because they get profit. And as you create more and more resources behind this network to continue to confirm more and more transactions, the profit doubles, triples, and quadruples in size. And so that's really where we saw a big boom in interest in the blockchain space, just because so many people were able to profit from this ecosystem. But what we can see is that just because we have a distributed ecosystem doesn't necessarily mean that all the resources are completely distributed. And so what I love about this graph is it shows mining pools. And so mining pools allow for individual miners to combine or pool their computational power together. And so that's really where things have changed in the last couple of years, is mining pools have become more and more popular because people have realized that they don't necessarily have enough mining power or resources behind them to be able to create these new blocks themselves. So they want to work with other people, and therefore they're able to share the rewards amongst themselves. And so what we just have to keep in mind is making sure that these mining pools still are still small enough to allow other players in the space to be able to compete in this ecosystem. And so we can see here that, BTC.com, for instance, has 27% of the mining pool. And so that's 27% of the computational power behind this ecosystem, behind this network. And so what we worry about is that if BTC.com ever reaches over 51% or over 50%, that, marginal threshold or that majority threshold, then they're actually able to overcome the network and dominate it themselves. And so what's good about this network is that we can see no one power is close enough to that 50% by themselves. And so, we talk about, both centralized and decentralized mining. And so a lot of companies like Litecoin and Dogecoin and others in this space have actually tried to create new algorithms to make it harder for one party to come to too much power in this mining network. And, when we talk about actually interacting with the blockchain ecosystem, we talk about, this cryptocurrency, and that's what's really bringing the profit to people. And so when we talk about using cryptocurrency, we talk about, Bitcoin wallet and taking it a step further to where we have these hardware wallets that can store our cryptocurrency. And so as we get farther and farther down the slide, what we're actually able to see is that we remove sorry, as we go further and further down the slide, we create different ways of storing the password to your wallet. And so whether it's using a hardware wallet or keeping your private keys on your computer or memorizing it, they're all different techniques. And by memorizing something like your private key, which is just a random string of letters and numbers, you're actually being able to keep the most secure way of holding your cryptocurrency. Because at the end of the day, if you're holding your cryptocurrency on a hardware wallet and you lose that hardware wallet, it's like losing your credit card. Except when you lose your credit card, you can just call up your bank and have them cancel it to make sure people aren't spending your money. But when you lose your hardware wallet, there is no centralized entity like a bank to be able to recover your keys. And so what we've been able to find is that so many consumers want to be able to remove that level of ambiguity and frustration of like having so much control placed into their hands that they've resulted to using centralized exchange services. And so Coinbase is a great example of that. Binance is another example. And so on these exchange platforms where you're buying and selling cryptocurrency, you're actually not storing the cryptocurrency yourself, but you're trusting a centralized entity like Coinbase to store that cryptocurrency for you. And so you actually remove a lot of the decentralized benefits of the decentralized world by using those centralized entities. And so just understanding those concepts so that you can be best informed when you're storing your own currency. And then we take it a step further and start talking about smart contracts. And smart contracts were really introduced with the Ethereum protocol. And so it's the idea of taking an agreement and making it implicit in code. And so what's really cool about Ethereum and these smart contracts is that these peers are able to communicate just like the Bitcoin blockchain, but they're able to run computational programs on the blockchain as well. And so the idea behind it is creating these scripts that are automated. And so, for instance, an example of this script could be if I want to enter an agreement with Fernando and basically say, okay, we're going to bet on a basketball game. It's Lakers versus Clippers. And I really think that the Lakers are going to win. Fernando really thinks that the Clippers are going to win. Well, I don't trust Fernando and Fernando doesn't trust me. So we want to be able to have some sort of decentralized party be able to make the final transaction of who to send the winnings to. And so what me and Fernando can actually do is we can each send $10 worth of Ethereum into this smart contract. It'll live and store in that smart contract until the results of the game come out, in which case the smart contract will actually be able to automatically execute who is right in this ecosystem or who is right in this negotiation, and then be able to send the money to the correct party. So that if the Lakers win, then I'm able to receive the money without having to worry about that trust with Fernando. And what we'll talk about a little bit later on in this presentation about use cases is we've actually been able to develop these smart contracts into something that's really cool and complex that allows for decentralized finance applications. And so when we talk about these smart contracts, there's two important terms to take away. The EVM, which is the Ethereum virtual machine, which is this ability to actually run and execute smart contracts, and gas, which is the power behind smart contracts. Because every single time a smart contract gets executed, it's going to take up somebody's computational power. And so what we want to ensure is that I'm not being malicious by just submitting a whole bunch of smart contracts that take up a whole bunch of network power and create a lot of congestion. But instead, we want to be able to say, okay, I need to have stake in the game. So I'm going to put up $10 worth of gas, and basically this smart contract is going to run as long as that $10 is continuing to fund the smart contract. And so that way, it's really making sure that I am placing a lot of value on these smart contracts. And so when we think about Ethereum as a whole, it's not for everything, right? And so we really want to understand that when blockchain is useful and when it isn't, because you shouldn't use a blockchain unless you really need it. And centralized databases by far are more efficient and have a lot less headache. And so we want to make sure that we're taking in proper considerations before choosing this blockchain and choosing which network we want to build on. And so going back a little bit to when we were talking about these mining pools, one term that often comes up is cannibalizing these pools. And so we want to make sure, again, that we're distributing this mining power throughout the ecosystem as a whole, so that whether or not it's Bitcoin or Ethereum or any other blockchain out there, that it remains decentralized. And so we talked a little bit about double spending earlier. And so again, this is the concept of making sure that when I have $100, I'm not able to send that $100 to two people. And so it's verifying that every single transaction that I process happens before I can process another transaction. And so that's why these blockchains remain linear as we move forward throughout the chain. And so what we've actually seen is, because of this concept of decentralization, is a lot of governments and entities have been able or have attempted to try and actually blacklist some of these protocols. And so the idea behind this is they don't actually want to give up that power that these decentralized blockchains allow for. And so one example is China. And so China has actually been able to, some successfully and some unsuccessfully, be able to control who's able to connect to these blockchain networks, just because they do still rely on internet infrastructure. And so at the end of the day, the objective of this is to censor Bitcoin addresses that are owned by certain people as well. And so one example is Gary Johnson, to prevent them from spending any of their Bitcoin. And so what we can also see with blacklisting is blacklisting certain actors. So many of you guys probably heard about that Twitter hack that happened a couple months ago, whereas a couple individuals hacked into Twitter, hacked into a bunch of individuals, prominent individuals' accounts, and posted on their behalf a message telling people to send Bitcoin to a specific Bitcoin address. And so what we're actually able to see is that if we're able to create a consensus among all the nodes, the miners in this network, of saying, okay, whoever owns this Bitcoin address is malicious, and so we don't want to transact with them, then if enough nodes in the network agree to that, then you can actually stop someone from sending transactions in the network. But because of the decentralized nature of things, more often than not, that doesn't happen, because people believe in this free and libertarian movement where everybody can interact with this blockchain. And so we can also talk about selfish mining as another attack vector. And so this is really delineating when it's profitable and when it isn't to mine. And so once the network almost catches up to their chain, example being like mining the chain that they thought was the longest, but isn't actually the longest, then you can actually publish the next block and try to create a new chain. And so what we see from this is that people can actually create different forks within this network. But as long as we keep a decentralized ecosystem within this network and trust that all of the parties within this network are going to remain honest, and trust that many of them are going to want to continue to push the longest chain further, then this doesn't happen very often. And so that's how we're able to prevent it. And so when we think about blockchain is a very specific application or specific data structure of distributed systems. And so the concept of distributed systems as a whole is creating a network of independent nodes, which each represent a certain process, which are able to talk to one another. And so the end goal of this is to accomplish a common goal. And when we're creating these networks, it's really important to understand what are the qualities that we want to create for these networks. And so we often think about the CAP theorem. And so the CAP theorem is a fundamental theorem for any distributed system pertaining to achievable properties. And so we talk about consistency, availability, and partition tolerance, and you can only have 2 out of 3. And so what we were really able to see is that different blockchains are able to prioritize different things. So some have consistency and availability, some have consistency and fault tolerance, some have availability and partition tolerance, but no blockchains are able to match all three kind of variables of a blockchain, or 3 traits. And then we got into talking about the Byzantine fault tolerance problem. And so this is really how we think about creating these network decisions. And so the Byzantine fault tolerance problem is really aiming at this idea of having a commander talking to 2 lieutenants. And so if this commander talks or sends a message to both lieutenants saying to attack, but Lieutenant 2 is acting maliciously, then what do we do when Lieutenant 2 says to Lieutenant 1 saying, hey, the commander told me to retreat, we need to retreat? Because now this creates a frustration point in the network. And so what we focus on is creating a consensus so that we focus on the majority of parties in this network. And so, spoiler alert, there's no solution for 1/3 or greater corruption. And so what we really want to ensure is that no one party has more than 1/3 of the network under control in this ecosystem. And so when we talk about proof of work, this is the consensus algorithm that's specifically behind Bitcoin. And one of the biggest criticisms of it is the energy consumption. And so what we can see is that Bitcoin actually consumes more energy than most countries do, including Czech Republic, Chile, and Austria. And I see a question in the chat here. What platform are they using? The distribution between the speaker and the slides looks super good. All right, I'm gonna take the second comment as just talking about how you can see my name and the slides. I'm glad you like it. I'm trying out this new tool called It's in beta, but let me know your thoughts. When we talk about which platform are they actually using, I'm gonna go back a couple slides. Because really when we've been talking about, what we've been talking about so far is agnostic to most blockchains. So when we talk about proof of work, we're specifically talking about Bitcoin, as well as most protocols. Ethereum is currently using proof of work, although a lot of blockchains are trying to move to a proof of stake proof of stake consensus algorithm, which we'll talk about in a few minutes. But most blockchains today do use proof of work just because it's been proven to work the most often. But great question. And so, as I mentioned, we're going to talk about proof of stake as well. And so, whereas proof of work is taking the concept of, okay, I have a computer, I have hardware that's associated with that computer, that's built into that computer. And so I am going to allocate the hardware in my computer, which is a finite resource because I don't have infinite like bundles of hardware. So that's a finite resource. And so that's what allows me to kind of I'm able to stake or, work on these transactions using this hardware. But the idea of proof of stake is shifting away from hardware, which really focuses again on energy consumption. And so moving away from energy consumption, proof of stake is focusing on how do we stake actual money. And so rather than staking my computational resource behind the transactions that I want to validate, I'm instead going to say, okay, I really think that this transaction is valid. I'm going to put $100 on the line to verify that this transaction is valid. And so that way, if the network as a whole says, hey, we actually don't think this network or this transaction is valid, we think you're acting maliciously, then I'll actually lose that $100 that I've staked on the transaction. And so, whereas the first one is just wasting computational power, the second one is wasting money, which some equate to a higher level of stake. And so what we can actually see is that there's this defense of nothing at stake. And so what we found is that proof of stake was theoretically great. It was more environmentally friendly. It doesn't require wasting resources, and it solves a lot of the proof of work's problems, but it's a trade-off. And so what it's actually just trading off is the fact that now the rich are going to continue to get richer because they're able to put more stake on the line and able to control more of the network as a result. And so what Nothing at Stake talks about is just, okay, how do we create a truly fair and a truly decentralized blockchain network for the masses? And so when we talk about these blockchain networks, it's really important that when we start to actually develop them, that we talk about, the use cases that are applicable for these networks. For most of this lecture series, we've really focused on and emphasized payments, just because that's the core, solution, or that's the core use case behind Bitcoin and many other cryptocurrencies. That's the most used solution currently for being able to send money, and the original solution for being able to send money peer-to-peer. But when we talk about other use cases that aren't purely financial in practice, we have to ask ourselves a couple questions. Because at the end of the day, a centralized database will always do what you need more efficiently than with a blockchain. And so instead, rather than talking about efficiencies, we want to focus on, the social aspects. And so the social aspects include, are we working with multiple parties who do not trust each other to agree on the contents of a shared database? And so that is the fundamental question that I encourage all of you to ask yourselves as you continue to evaluate and create your own blockchain use cases. And so taking this a step further, we begin to identify a set of business processes that we want to improve. And so first we have to study the process task by task and identify the steps of where we're going to be losing efficiency because we're using a blockchain, and where we might potentially have a greater financial cost associated because we're having to develop this from scratch oftentimes. And so we're really focusing again on that lack of trust or a coordination failure between parties as being the core reason of why we want to use a blockchain. And so considering these pros and cons is really important within the context of itself, to understand the long-term repercussions of these blockchain networks that we're developing and creating ourselves. And so one of our members actually created a great graph about should I use a blockchain? And so these are, 1, 2, 3, 4, 5, 6 questions that you guys should ask yourself before you start using a blockchain. And so at any point, if you answer no, then there's a good alternative of what you should use instead of a blockchain. And so what we've actually seen over the years is a lot of companies and individuals kind of skipping through these very important questions, trying to create blockchain concepts and applications that have gone on to fail because they didn't ask themselves these questions. And if you don't ask yourselves these questions, then what you'll see is competitors will come into the space, build the same use case as you, but put it on a centralized database. And as a result of it, be able to outcompete you because there probably isn't a need for this decentralized network where so many parties are having to work together in coordination. And so we can even take it a step further and talk about how, we have to create this crypto economic ecosystem. So this is proved with a simple example of incentives involving midterms of professors and students that we use to realign incentives to create a better system. And so an example is studying in groups. So we're setting up the primitives to understand the technological way blockchains prevent attacks. And so we have certain properties that we need to exist within blockchains. We're going to take a look at these properties in a new light and see how cryptography and hashes and math fit together within the science of human rationale. And so we'll actually be using crypto economics to explain how Bitcoin protects against the attacks you learned about in all the lectures thus far. And so in this example, we can see that, all the students want to get a high score on the midterm. And at the end of the day, the teacher wants the students to learn the material. And so if we're able to work together in groups, then we're able to see that, okay, students are able to receive higher scores on the midterm and students understand the material better by studying together. And so when we're actually creating these ecosystems, we're having to understand the behavior of the people in these networks and understand how people can work together to achieve a common goal. And one question here is, could you please share with us the questions on the slide, as even the maximize window, you cannot read them. Oh yes, so sorry about that. And so what I'll do actually is I'll also share this with you with you after today's presentation. I'll go ahead and send you guys a link. But I also just made the slides a little bit bigger so that hopefully you guys can read them. And I'll keep myself off to the side so hopefully I don't get in the way. I'm sorry, you still can't read it like that. In fact, what I'll go ahead and do is there's a great, in fact, I've got it, not to divert, but let me just send in the chat really quickly, just because I just had this up, a great article that one of our members, Wesley Graham, wrote a couple years ago that's still very applicable. And it's really focusing on how do you build a better, simpler guide to using blockchain use cases. And so I just posted a link to that in the channel. I highly encourage you guys to check that out, as that Medium article does include this graphic and includes a lot more depth and rationale into creating these blockchain platforms and use cases and what makes a good use case. Because at the end of the day, that's what's going to bring the money and success to you as an individual and as a creator. And so when we think about crypto economics and how it relates to that very simple example of midterms, we talk about it in relation to cryptocurrency. And so it's the application of cryptography and economics to align incentives between parties. And so cryptography is for security, whereas economics is for the incentive alignment. And so what we're able to see here is that it's similar to mechanism design, where we're actually combining different, variables of both the technological as well as the social factors that go into creating these networks and ecosystems. It looks like I sent the I just realized I sent the link to just the staff behind here. Let me send it to all of you guys attendees. There we go. Hopefully you guys can see it now. And so what this is really considering is that we have to focus things on both a technological front as well as a social front. Because at the end of the day, these are people that are going to be interacting with this network. And so how do we make sure that this interaction is beneficial to all the parties, to the parties that want to profit off of it from owning cryptocurrency, as well as the ones that want to profit off of it by contributing back to the network in the form of mining or validating transactions. And so what we've been able to see over the years is that while this started as a, anti-corporation, anti-enterprise movement, enterprises have actually been able to adopt this technology to be able to bake a lack of trust into the greater ecosystem as a whole. And so worrying also about the lack of trust between enterprise entities. And so there's a few, broad classifications of enterprise blockchain use cases, really focusing on solving coordination failures between parties, horizontal integration. So how do multiple companies work together to work towards a common goal, and creating self-sovereign decentralized networks that can be independent of regulators or specific parties. And so what we've seen with this adoption of enterprise blockchain use cases is a movement away from public blockchains to permissioned or private blockchains. And so we've talked largely about public blockchains being Bitcoin, Ethereum, Litecoin, Garlic Coin is even a coin that's out there, and there's so many more. Enterprises have been able to shift these networks slightly to create consortium blockchains and private blockchains entirely. And so for consortium blockchains, we'll touch a little bit more in a second, but you've got R3 and Hyperledger, which are really leading the way. And then on the private blockchain side, you've got Chain, you've got JP Morgan Quorum, as well as Bank Chain. And so the real key difference between consortium blockchains and private blockchains is consortium blockchains are building these consortiums of multiple parties and people to contribute towards creating a foundation for companies to build on top of. And so when companies are building on top of these foundations, they're actually creating their very own blockchain network that's fully controlled by the people that they allow into that network. And then for private chains, it's very similar, where JP Morgan really wanted to have an ability for handling back-end transactions for their core payments needs. And so they created this JP Morgan Quorum, which allows them to integrate this into their current infrastructure and change the way that their payments are actually handled. And what's really cool about this as well is that all of these tools are open source, so that any individual can take this code base and create a new blockchain off of them, or continue to build on the existing blockchains behind these applications and these use cases. And so diving in a little bit deeper to some of the big names. So Hyperledger is probably one of the most notable companies in the space. They spun out of or are part of IBM. And so they've really had the full support of the Linux Foundation and all of IBM, which is a huge corporation able to really build this into many applications within the industry. So one of the notable examples a few years back was Hyperledger collaborated with Walmart for a supply chain use case. And so they were able to actually track and trace lettuce on the blockchain to ensure that lettuce wasn't going bad, because they were having a lot of problems with salmonella and E. coli infecting people. And so they wanted to create a better way of creating these supply chains. And so how Hyperledger works from kind of just a back-end standpoint is people that want to get involved will pay $10,000 per month for banks and other corporations that are trying to take advantage of this to get access to developers and resources and a lot of just tooling and information. Because at the end of the day, even when we're providing consulting services for Fortune 500 clients, it starts with education and helping people to understand where these applications really begin. And so what's really awesome is that by taking this course, that you guys have already bypassed all of that education. And so now you guys can start diving into some of the deeper concepts or building out your own applications. And so just to go quickly, we've talked about Ethereum a bunch. The Enterprise Ethereum Alliance really focuses on leveraging the Ethereum network for enterprise applications, whether that's building on the existing public Ethereum blockchain or taking the Ethereum blockchain and privatizing it between just a few parties to take advantage of the smart contracts within blockchains, but the smart contracts within Ethereum without having to worry about this large network with a whole bunch of other parties and network congestion for fees. Consensus is a company that is really focusing on advancing this space. And so they primarily focus on the Ethereum protocol, but they also contribute to other protocols as well. And then R3 has really come to light in the last couple of years as they really focus on banks and financial institutions. R3 started out as a banking company originally and then transitioned to a blockchain company, really focusing on the implementation and the build out of their Corda protocol. And so what's really awesome about R3 is they take things from both a technological standpoint, but they really also focus on the regulatory side of things as well. And so the Corda blockchain is focused on meeting financial regulation needs. It's focused on interoperability with existing financial tools and instruments, and has been a big player in the space of CBDCs, which for those of you unfamiliar with that term, focusing on central bank digital currencies. And so central bank digital currencies, or CBDCs, are being explored by just about every nation out there as an alternative for existing financial use cases or financial applications and backends. And so up until now, we've really been talking about, what you guys have already learned up until this point as just kind of a review, because this is the foundation that allows us to do a deep dive into use cases and applications and understand what really shines and is important to highlight in this space. And so as we dive in a little bit deeper into specific use cases, one use case that we can talk about is in the automotive industry. And so this is a great use case of how we can actually have multiple use cases within a single industry. So for the automotive industry, a few use cases that are being explored by partners such as Mobi, which is a consortium founded actually by Blockchain at Berkeley members, focusing on driving innovation in the automotive and blockchain ecosystem, as well as other parties. They're focusing on learning about vehicle and auto parts supply chain. And so the idea behind this, very similar to the example with Walmart that I just briefly talked about, is streamlining and securing data and record management so that the parties that are within and involved in the supply chain are able to easily communicate with each other and be able to find where faults in the supply chain are occurring to ensure that no one party is acting maliciously. But then also when mistakes happen and, the food, or in this case, the auto part fails to perform what it's supposed to perform, then being able to go back in the chain and be able to see right away where the fault or problem occurred. Another example is machine-to-machine payments. And so this is applicable outside of the automotive industry as well. But one idea as we move towards autonomous cars is to be able to make it for autonomous cars to be able to easily pay each other. And so the idea behind it is if I'm jumping on the freeway to drive from Los Angeles to San Francisco, maybe that trip will normally take about 6 hours, let's say, but maybe I really need to get there in 5 hours. And so what I could do in theory is be able to send very small payment amounts to other cars on the road to be able to move over into a new lane to allow me to fast track my driving experience or my drive to San Francisco. And so we can also see this application being used for like drive-throughs. And so if I want to be able to pull up in my car to McDonald's, then making it really easy for my car to be able to send payments to McDonald's without me having to take out my credit card and hand it to an individual. And so again, really focusing on multiple parties in this ecosystem that don't want to be able to, or don't want to have to trust each other. And then car sharing as well. This is really, this is somewhat similar to the example of being able to drive with, fares, but being able to create these decentralized ride sharing applications. And so I don't know if you guys are too familiar, but Uber and Lyft almost had to stop all operations in the state of California because the state of California found that they weren't treating their drivers right. And so they want to create more regulation in that place. But what we could actually do is convert this to a fully decentralized application where we don't have to worry about a centralized party like Uber and Lyft being the gatekeeper of all of these profits. And so therefore enabling the drivers in this ecosystem to be able to accept peer-to-peer payments directly from their consumers and be able to profit off of it more so than they are right now. We can also talk about banking and financial institutions and how they've been able to take advantage of this technology. Ripple, a company that I've worked at in the past, is built to make traditional banking systems more efficient. And so they use a technology called RippleNet and on-demand liquidity to be able to make it very easy for financial institutions and individuals to be able to send cross-border payments. So I'll give you two quick examples. One great example is with MoneyGram. MoneyGram is a financial institution that many of you guys are probably familiar with that enables users to be able to send money across borders relatively easily. They've got these little kiosks in gas stations and convenience stores so you can be able to pop in, insert your cash, and then MoneyGram will handle all the transactions to make it easy for me to send Fernando money despite us not being in the same country. The only problem with MoneyGram is they have really high fees. And so Ripple actually partnered up with MoneyGram to be able to reduce those fees. And so the way that Ripple is able to do that is, let's say so where the fees come in primarily is one, because it's a centralized institution, but then two, just because there's also foreign transaction fees. And so when I'm trying to convert my US dollars to pesos, let's say, then there's a middleman in that middle that's charging a lot of money for that conversion. And so Ripple actually abstracts a lot of that by being able to say, okay, I'm going to send USD. USD is going to be sent to Ripple Solution. Ripple Solution is instantly going to be able to convert that to their native token XRP. XRP is then instantly going to be able to be converted into pesos. And then Fernando is able to receive the money in his own local currency. And so the way that Ripple has actually built out this technology reduces a lot of those fees. And one notable example is how I actually transact internationally. And so I use a tool called Flash FX, which is powered by Ripple. And because I was born in Australia and I have a bank account in Australia in addition to a bank account in the US. And so normally when I'm sending money between those two bank accounts, I will pay somewhere between 5 and 8% in transaction fees, depending on which service I'm using. But with Flash FX, I'm able to reduce that transaction fee down to about 1.5%. And so it's really able to cut down on the fees that I'm able or that I'm required to pay every single time I want to send money to a cross-border institution. Goldman Sachs is pretty stealth in the space, but they are slowly growing their blockchain and cryptocurrency unit and team. So looking forward to seeing what they do there. JP Morgan, they've been very critical of Bitcoin publicly at times, but they also do have their own blockchain called Quorum, which is fully open source. So, they're getting into it from a private blockchain standpoint, but not necessarily from a public blockchain standpoint. And a lot of banks that we see nowadays are at least doing proof of concepts with companies like Hyperledger, the Ethereum Enterprise Alliance, and R3 to build out these central bank digital currency platforms. And so I think, as we look to the future, these next couple of years are going to be really telling about the applications of blockchain for financial institutions, because right now it's mostly been small use cases. And then another great application is financial good use cases. So, one company that's really notable for creating the term banking the unbanked is Omise Go. And so Omise Go is the product of its parent company, Omise, which is one of the largest payment facilitators in Southeast Asia. And so Omise was already processing millions, if not billions of dollars worth of payments on a weekly basis. And what they found from their customers is, especially with Southeast Asia, was that people were trying to send money from China to the Philippines to Singapore to Vietnam, and they were really struggling to do so. And they were really struggling also to have access to traditional banking infrastructure, because maybe they don't have a bank account because of a lack of internet or just a lack of civilization. And so what Omise Go is trying to do is to enable the users in the network to be able to easily send money to one another, regardless of kind of their background, without having to go through KYC, which is know your customer, where you have to take your driver's license, submit it to the bank, take your passport, submit it to the bank, go through all of these password verifications and these regulatory and compliance checks, but just putting the power directly in the hand of the individuals. Another use case, which we've already touched on a little bit, is supply chain and provenance. So transparency for consumers, so that I, as an individual, understand where my car parts are coming from or where my food is coming from. Identity management, and so that's actually the idea of taking my personal information and storing it in a way that's able to create a digital identity on a blockchain, so that I, as an individual, don't have to worry about showing my passport everywhere I go, but instead I can show this digital identity that's fully decentralized, but still secured by myself. The energy sector and the environmental sector are focusing on incentivizing environmentally conscious behavior. So we were working with one company a couple of years ago, which wanted to empower its employees to be able to invest in social good projects. So this company had, let's say, a fund of $10,000 that they were going to allocate every year towards financial good use cases and towards donating to nonprofits. And so what they wanted to be able to do is actually put that power into the hands of its employees, so that its employees could dictate where that money is actually going. And so, and then we also have worked and explored use cases in the energy sector, where energy companies want to be able to make it so that, there's a lot of burdensome processes currently in the energy sector, just between all the regulation and the paperwork, and oftentimes, like with environmentally friendly cars like electric cars, you get a subsidy, or at least in the US, you get a subsidy for owning an electric car. So you oftentimes will get a check for a couple $1,000s as a way of saying thank you for being environmentally conscious. And sometimes those payments don't go to the right individuals, or the paperwork just behind it can be falsified or lost during the process. And so creating this aggregated store of data between multiple parties that's constantly being able to stay up to date is really important. But when we're creating all of these use case applications, regardless of the industry, regardless of the use case specifically, we have to focus on the scalability trilemma. And so this is where we're really focusing on picking 2 out of the 3, between security, decentralization, and scalability. And so similarly to cap theorem, you can't have all 3. You really just have 2. And so again, these are considerations for creating your own blockchains to ensure that you're creating these in a way that's going to be sufficient for the long run. And so we can talk about scaling techniques, whether it's vertical scaling, where we're actually adding more resources to the individuals to give them more power in this network, or horizontally scaling by creating, adding more machines of the same computational power in the network, so that there's more parties involved contributing to the same thing, but not one party getting too much power. And then there's diagonal scaling, even, where we are creating more machines that are also more powerful. And so continuing to push both vertically as well as horizontally. And so there's even layers of scaling. And so when we talk about scalability, we like to break it down as layer 1 versus layer 2. And so layer 2 is really focusing on off-chain scalability. So building platforms that allow for existing chains to become faster by using third-party services. Whereas layer 1 scalability is focusing on changing the initial blockchain protocol at hand to actually make it more efficient itself. And so here's just a few examples of kind of what this ecosystem looks like, or some examples of layer 1 versus layer 2 scalability. And so an example of layer 2 scalability is payment channels. And so the idea behind payment channels is, let's say me and Fernando want to be able to send money to each other really easily. And let's say that we're living together, and so we're constantly buying food for each other, just because, we're switching off who's running errands. And so every single day, maybe, maybe I'll go out for lunch, and pick up lunch for us. Then maybe Fernando will go pick up dinner. And so there's a lot of transactions that are happening. And the problem with all of these transactions is it can actually clog these networks. And it can clog these networks because Bitcoin can only handle about 5 to 7 transactions per second. Ethereum isn't much better at about 15 transactions per second. And then some of the newer protocols out there can handle about 1,000 transactions per second. But still, it's really problematic. And so what we want to be able to do is create this payment localized channel between me and Fernando, where we're actually transacting off the chain for a little bit. And so the idea behind it is, if I have $10, I'm going to send it to Fernando. Now Fernando has $10. Now he's going to send me $5. Now I'm going to send him back $2. And so, my math isn't the best, but I think I have about $3 now, and I think he has about $7. And so then what we're able to do is say, okay, we trust each other enough to be able to handle these kind of constant transactions, but then we want to kind of put them on the chain eventually. And so what we'll do maybe on a weekly basis is say, okay, at the end of every week on Sunday, we'll confirm these transactions to the blockchain. And so rather than sending putting every single one of these transactions on the blockchain, we'll just put it as a final transaction, just saying, okay, at the end of the day, Liam has $3 and Fernando has $7. And so there's a lot of protocols that are trying to conquer this from both a layer 1 and layer 2 scalability perspective. And, one question that we get a lot when we talk about blockchain is, the question of, is anonymity only for drugs? And so what we really want to harp with our content is that it's not. It's so much bigger than that. Although some of the early applications were used for like the Silk Road and drug applications, we've been able to see a lot of companies actually come into this space to be able to track and trace the payments in this network. Because one thing to consider is that blockchains are not anonymous, they are pseudonymous. And so the idea behind that is, okay, you might not know who I am individually based off of my public key, but that public key, that address where you're sending the cryptocurrency to, is actually owned by me. That's kind of my identity in this ecosystem. And so, mistakes are easy to make, and it happens all the time. And so with clustering, we're able to actually be able to kind of track and trace where payments are being sent in this network and which parties are interacting with these payments in the network. And so there's a lot of companies out there like TRM Labs and Elliptic and Chain Analysis that are actually hired by governments and companies to be able to track and trace these payments. But then as you've got companies that are trying to track and trace these payments, you also got companies that are trying to make it more anonymous. And so you've got companies that are focusing on, being able to actually mix these currencies. So, financial institutions always have to, as part of their compliance, make sure that the money that is entering that financial institution is clean and isn't associated with financial wrongdoing. And so what bad actors will try to do is try to place these payments into, different bank accounts. So this is where we see like offshore bank accounts coming into play. There's ideas of layering. So, transferring money to multiple different institutions. And so spreading it out only for you to just bring it back in. And then integration. And so actually using different entities or different individuals as a laundering front for money. And so whereas many of these terms have been used in centralized financial applications, we also see them being used for decentralized applications. And so there's actual companies out there like Dash, Monero, and Zcash, which are specifically trying to focus on privacy preserving applications. And so Dash is using concepts like CoinJoin to be able to actually move money around constantly between accounts to keep the money kind of anonymous or just add a little bit more ambiguity to the ecosystem. Whereas Monero and Zcash are using cryptography to really focus on not sharing the entire information about the ledger as a whole. And so, for instance, if I wanted to go to Zcash, Zcash's public ledger and be able to see all the transactions, I wouldn't be able to see where all the transactions are being sent because there's layers of cryptography that are able to abstract that information away to ensure that users in this ecosystem are actually remaining anonymous. And so, one great example, as our former president, Gloria Zhao, would say, is, this concept of introducing privacy solutions that include computing ring signatures, which is what Monero uses, or extra coin mixing step, which is what Dash uses, or homomorphic encryption, such as, or using encryption such as zero knowledge proofs, which is what ZK, Snarks, and Zcash uses. These are great tools for adding anonymity, but the caveat of it is that these transactions are going to become slower and they're going to take up more space just because we're putting more work into all of the transactions. So again, as we think about the trade-offs between centralized and decentralized ecosystems, we also have to think about the trade-off between private and public information schemes, just because there's trade-offs to all of these decisions. And so as we take this a step further, we can actually talk about applications that we can see in the ecosystem right now. And so one application that many of you guys have probably heard of is decentralized finance. So MakerDAO was probably one of the first notable companies to enter the space by creating their own stablecoin. And so they created this stable coin called DAI. And so it's really designed to remove a lot of the frustration points of Bitcoin, of the fluctuation in prices. You know, I think I even saw some messages in the chat earlier today about, you know, Bitcoin's price dropping below 10,000. And so Bitcoin's price, you know, even just in the last 2 years has fluctuated everywhere from like $3,000 at the lows to $20,000 at the highs. And so MakerDAO created a stable coin to try and combat that. And we can go into depth at a later time about that. But if you're interested in learning more, I definitely recommend you check out the white paper for that. Uniswap is the idea of creating a decentralized exchange so that parties can be able to exchange different currencies for other currencies without having to use a centralized service like Coinbase. The blue icon at the top is called Wi-Fi. And so for those of you who have been following kind of the crypto news in the latest weeks, you'll be able to, you've probably heard of Wi-Fi because the idea here is yield farming, which I won't go into, but if you're interested in finance, I highly recommend you check it out. Aave is doing some awesome stuff with creating loan systems. They created this process called flash loans where individuals are able to get loans in a decentralized manner. And all of these companies have contributed towards making the space so big that there's over $8 billion in assets currently being traded and locked up in the DeFi ecosystem. And this ecosystem is so large, in fact, that this picture right here is a great way to demonstrate just all of the different applications, from payments to infrastructure to derivatives, stable coins, insurance, prediction markets, investing, custodial services, right? And so if you're trying to break into this space and you come from a financial background, there's a lot of ways to get involved. Another great application is NFTs in gaming. So one of the most famous applications of NFTs is called CryptoKitties. This application was actually so popular when it first came out that it slowed down the entire Ethereum network like by hours. It just got completely backlogged because so many people were trying to trade and interact with these CryptoKitties. And so the idea is creating these digital non-fungible tokens. So meaning that they can't be spent like a normal dollar, and meaning that they can't be broken down into pennies and cents like a normal dollar can. But instead we're creating these digital assets. And so these digital assets are able to be traded to one another based on the rarity of the items. And so, you know, different CryptoKitties have different rarity. And that's what brings the kind of financial backing to them. And so this is created by a company called Dapper Labs, which also just recently came out with their Flow blockchain. And so they actually have a collaboration going on right now with the NBA, where you can buy NBA players' digital cards on the Flow blockchain and be able to send them in a peer-to-peer manner and be able to collect them as you would physical cards. Then on the side of gaming, we've got two awesome companies such as Forte and Mythical Games, which are really focusing on how do you create these in-game experiences that are able to leverage decentralized technology. And so what's really cool about this is taking a concept like in-game skins or add-ons. So for instance, if I'm playing Call of Duty, then I might want to buy certain, you know, bonus packs or enhancements in the game. Well, once I buy those bonus packs and enhancements, they're just tied to me as an individual. Well, what if I want the ability to be able to then buy those packs and then send them to other people? Or as I unlock certain you know, goals or applications or, you know, features within this application, then how do I be able to send these you know, assets to other individuals within the game? And so those are kind of the problems that Forte and Mythical Games are creating, as well as integrating financial use cases. And when we talk about all of these blockchains, one thing that's really important to consider is interoperability. And so a few notable companies are Interledger, Cosmos, and Polkadot. And all of these companies are taking slightly different approaches at creating interoperability between these different blockchain protocols and applications. So for instance, if I wanted the ability to be able to send 10 Bitcoin to Fernando, but Fernando wants to be able to accept it as Ethereum, then Interledger, Cosmos, and Polkadot are all taking steps to be able to make that possible in the near future. And so up until this point, we've really just been talking about what's been happening so far. But, you know, we think it's really interesting to think about a hypothetical world where blockchain is integrated into everything that a person does. And so let's take an example where I leave the apartment where I spend the night, and as soon as I leave, sensors are able to detect my departure, and a company is able a company behind those sensors is able to use smart contracts to confirm that I didn't break anything, and it'll instantly pay me back my security deposit. So for instance, if I'm living in an Airbnb, this is where the application could fit in. But now let's take it a step even further. I order a coffee from Pete's on my smartphone. The coffee has an entire supply chain history, including fair trade certification and soil analysis from the farm. The coffee beans were harvested from. My purchase also includes the option for purchasing carbon offsets for the coffee's carbon footprint, and I want to take that option. And so many products include this option, as well as other micro donations embedded into the price that offset carbon and water or contribute to charitable causes. And so I want to be able to see where these donations are going because it's a public cryptocurrency. And so I'm able to see the entire lineage of this ecosystem. And so as we take this a step further, I want to call my car, but it's not really yours. It's plugged into an autonomous ad hoc swarm of vehicles, such as like up here we have gig cars or zip cars, or having the ability to be able to just rent cars ad hoc. And in this ecosystem, accidents are rare, but when they do happen, the insurance agency analyzes usually like video footage via machine learning trained bot, and is automatically able to give the victim in the accident the appropriate payment for the accident. Except it's not really, except in this make-believe world, it's not actually an insurance agency. It's a smart contract that pulls together the funds of multiple owners and charges people the exact expected value of car insurance, taking no profit. And so that near exact probability of accidents is known because every accident that has ever happened is recorded on the blockchain. And so all of this is able to happen instantaneously and in a decentralized manner because all the parties in the network are able to communicate very quickly and rapidly with the other parties in this ecosystem. And now I head off to my company headquarters to work for the day, except your work isn't really work. It's all voluntary because the blockchain ensures a universal basic income for everyone. And when you're an engineer and researcher by trade, primarily, because you want to help push the boundaries of human knowledge, but your company isn't really a company either. It's a decentralized autonomous organization consisting of individuals from around the world who voluntarily sign up, receive compensation, and pay raises based off of the quantity and the quality of their research findings. And so really focusing on this gig economy idea that so many companies have already tried tackling, such as Lyft and Uber. And so what we can use is oracles, which are basically the mechanism of truth behind this, who are basically going to confirm or deny the work that you have contributed to this ecosystem, and then be able to fund you appropriately for the work that you've brought to your company. And so what we've actually seen here is that we're actually starting to create a DAO, a decentralized autonomous organization that is fully run by the ecosystem at large. But for a few of the functions left in society, they still require a government. And so that government is run entirely by a democratic futurarchy where the markets decide which policies should be implemented, completely removing the possibility of corrupt politicians who know little to nothing about the fields that they write legislation for. And so this is actually taking the idea of, you know, putting the power back in the hands of the individual citizens within a society, rather than relying on a single government power to make all the decisions. Because I think we can all resonate with the idea that governments oftentimes make decisions that don't make sense to consumers on the ground. And so, you know, rather than entirely blockchain era future, most likely what we'll see is a partial integration. And so this is what we as Blockchain at Berkeley really hope to train you on, is to understand the problems that we've discussed kind of throughout this use case, where, okay, you know, coordination failure meets social entities. And so maybe instead, anytime you go to the doctor, you'll be able to see your summary signed off by your doctor, sent to you for a confirmation signature before it goes to the insurance company. And so you'll be able to have your health records more transparent to you, but only to you, made possible by cryptography. And so what we're really focusing on is just weighing the balance, right? And so a fully decentralized economy doesn't necessarily make sense at all levels. It's also very hard to just integrate because we've got this concept of oracles. And so oracles are, you're still relying on one centralized party of truth at certain points throughout, especially when you start interacting with the physical world. But we're just trying to at least make things more decentralized rather than focusing on fully decentralized. And so this is where we really start to talk about problems with blockchains. We've got technical shortcomings, we've got non-blockchain challenges, and so that's really where the social problems come in. And then we've got really large barriers to adoption that we'll cover very briefly here. And so when it comes to technical shortcomings, I've touched on this a little bit, but Bitcoin's average transaction is right around 3. I think sometimes it hovers up to about 5 to 7, but you know, staying in the single digits. PayPal, you know, is focusing on, you know, the hundreds of transactions, which is really great. And since it's a private company, you know, it's able to scale still efficiently with hundreds of transactions per second. But then, you know, companies like Visa and MasterCard, where they're the backbone of our economies, they're able to take things even further to work on handling thousands of transactions per second. And so what we need to see in the future of blockchain is the ability for multiple companies to be able to handle thousands of transactions in order for these blockchain technologies to really scale. And so a question from Diego: how would the insurance contract sustain itself? If it works as a nonprofit, how would the business model work? Great question, Diego. So for these smart contracts, it really focuses on inputs and outputs. So when we think about the outputs, we focus on the insurance claims themselves. But when we think about the inputs, there are still going to be fees that individuals will have to pay into it. So just like I have to pay my car insurance every month, maybe I send $100 to, you know, Farmers Insurance or whatever company, then Farmers Insurance will take that $100 and maybe put about 50% or so towards an actual insurance pool, whereas they'll profit the other 50%. And so what we're focusing on is not necessarily removing that fee structure completely, but reducing it. And so instead, what I would maybe do is send just $55 a month to Farmers Insurance. $5 a month would be taken as fees to the people who built these smart contracts and this ecosystem. Because at the end of the day, there is going to be someone that profits. But then the other $50 goes to this collective pool, which is able to be distributed on a case-by-case basis. And so it's just really focusing on reducing the middlemen, not necessarily eliminating them completely, but just putting smart contracts in place of them. You know, I know we've already seen this slide a couple times throughout this presentation, throughout this entire series, but scalability is so, so important. And we've talked about scalability. We always have to keep in mind security, decentralization, and scalability, just because all 3 of them play into each other, and you're really only able to focus on 2 of them. And then, you know, other applications are non-blockchain challenges. And so, you know, one great example is with voting. Well, one example with voting is a company called Votes. It's a company that organizes blockchain-based election for private and hired clients. The technology has been used in trial runs since 2016. In 2016 specifically, it used it as a trial run for the Massachusetts Democratic State Convention, so on a relatively large scale, as well as for West Virginia, as well as for Tufts University's internal Senate election since 2017. And so, this is really cool to see where people have been able to build up these applications in the space, but we still have some problems. For example, governments are really wary of this technology because Votes, as well as other like-minded companies, have received several audits from the Department of Justice and independent auditing agencies, but without transparency of those audits. And so it's not very clear to the general public exactly how these systems work. Additionally, they require NDAs like most public companies do. And so, when there's not full transparency into the company as a whole, it's hard to really understand, what aspects are centralized versus decentralized and where that intersection is happening. This is a very similar concern to those in the audience who come from a technical background. You might be familiar with SHA-256, which is an encryption algorithm that's probably the most used in our world. And one concern about SHA-256 is it was actually created by the United States NSA, the National Security Agency. And so there's always been rumors and conjecture about the actual validity of how that encryption algorithm is worked and whether or not the NSA has a backdoor or keys to the cryptography behind it. And so, as we see the introduction of more and more private companies into the space, we as individuals just have to hold them accountable to remain transparent, to align with the original cypherpunk movement. Other implications that aren't specific to blockchains, but when we talk about supply chain use cases, we oftentimes talk about needing hardware applications. And so in the example of lettuce, I believe they use either QR codes or RFID chips. And so QR codes are those, random, it looks like kind of pixelated white and black that you've probably seen a bunch. And so those codes are actually being able to be scanned by, individuals or machines and be able to kind of track the lineage. But of course, there can be errors in either the machines that are scanning those QR codes or in the QR codes themselves. The same thing is true with RFID chips, which are little traceable chips, which can relatively easily be hacked. And so we just have to be mindful that as we interact with the physical and digital world and combine them at an intersection, that we're interlaying security into every step of the process. Because at the end of the day, blockchains are only as strong as the information that you put on a blockchain. Another example is the need for a wide supply chain traceability system. And so there's been a rise in kind of counterfeiting really high expensive wines. And so some companies have started to embed RFID chips into the bundles of grapes or on individual bottles of wine to be able to track them through the supply chain as well as track them through the sales lineage. So if you're going to a private collector of fancy wine bottles, you can easily be able to see all the previous owners of that wine bottle and ensure that the supply chain of that bottle wasn't tainted at any point. And so this is an application that has also been used, but again, you have to keep in mind the security concerns of the hardware that you're relying upon to make these sound systems. And so at the end of the day, we really just want to focus on, how do we create an ecosystem and this application network that everyone can interact with. And so another big barrier to adoption that we see is, how do people actually adopt it? And so one way that works, of course, is the government forcing everyone to use it. And so if the government actually interbakes this into the financial applications of a national currency, then that's one way. But it gets messy and it really just probably realistically isn't going to happen in the next couple of years. And so what we need to focus on instead is how do we make it really easy for people to join into this movement? And so one way we do this is through large consortiums where large companies work together with other large companies to tackle barriers to entry in this market. And so that's where you're really seeing companies like Hyperledger and R3 really shine because of the value that they bring collectively from all the companies in these consortiums. But then also we talk about poor UI and UX. And so when, throughout this series, you've seen a lot of fancy terms like cryptography, you've seen a lot of fancy terms like public key and private keys. And when we were talking earlier about, the trade-offs between using a hardware wallet versus memorizing your private key versus using a centralized exchange like Coinbase, there's trade-offs to not only the security that you have at mind, but also to the user experience of interacting with these technologies. And so what our space really needs is making it really easy for people to be able to abstract away some of the fancy technological language, so that making it as simple as me sending money to Fernando by sending it to his email address rather than knowing this random string of letters and numbers. And so a lot of companies are trying to tackle this space. One notable example is Ripple, who just came out with a product called PayID, which it creates these email address-like addresses. The only difference being the @ is now a $, and making it really easy for me to be able to send cryptocurrency to human-readable addresses. And at the end of the day, there's still just a lot of misinformation. And so what we've really been able to see from Blockchain at Berkeley's perspective over the years is how important education is, so that people understand that this is not just an application for people that are trying to use it for illicit purposes or illegal purposes, but that's an application that can be used to decentralize or put the power back into the hands of individuals, both good and bad. And so as I leave you all today, I wanted to give you just a few directions to get more involved in this space. At the end of the day, we need more people working in the blockchain industry. There's so many blockchain companies out there. I think there's over 2,000 or 3,000 different cryptocurrencies on the market right now. A bunch of companies that aren't necessarily working with cryptocurrencies directly, but working on the underlying protocols or working on auxiliary kind of applications to support the industry. And there's a lot of need for diverse perspectives and backgrounds. And so I highly encourage you that if this is something that sounds really interesting, and you're, say, in the finance space already, then get into the decentralized finance space. Or if you're in the enterprise space already, get into the enterprise blockchain space. Or if you're in the supply chain space, get into the blockchain and supply space. Because we need more people contributing to this ecosystem, because it's still so new that the possibilities have yet to be truly unlocked. And even if you don't come from a technical background, still get involved in this space, because as I mentioned, from societal problems to economics problems to design problems, we need smart people to be contributing to this space in a whole host of ways. Another great way to get involved is through Blockchain at Berkeley's weekly webinar series. So a lot of this content that you guys have heard in Spanish throughout these last 4 or 5 weeks will be repeated, but some of it will be updated, and we'll be focusing a little bit more on a deep dive about decentralized finance, as well as some newer applications that we've seen in the space. So if you're looking to enhance your skills, I definitely recommend checking it out, as we'll also be having industry speakers throughout every single week, or just about every single week, that will be talking about concepts that we teach in the class and how they relate directly to the industry. And then we'll also be having opportunities for knowledge or concept checks to be able to make sure that you're understanding the concepts that we're teaching. And then we'll also have office hours where you'll be able to have more private and intimate conversations with our core staff to be able to learn more about these technologies. And so I highly encourage you to sign up at tinyurl.com/babwebinar. Even if you aren't able to attend live because of the timing, I encourage you to sign up, as we'll be recording everything. And then we'll have different kind of components of the series at different times to make it as easily accessible to people in different time zones. Another great resource is the Berkeley Blockchain Accelerator. So this is an accelerator that Fernando's company was actually accepted to, and it was great having him. We started this accelerator only about 1.5 years ago, and it's a joint venture between Blockchain at Berkeley and the business school and engineering school on campus. And what's really unique about this accelerator is we don't take equity stake of your company, because we really want to focus on growing your company, and we don't want us to hinder that. And so what we really focus on is just pairing you up with the industry and building your personal and professional network to be able to grow in this ecosystem and get the resources needed to be able to take your product to an audience. Even though we only launched 1 year ago, we're the #1 university blockchain startup accelerator in the United States. And it's by the magnitude of difference is huge. I think our head of the accelerator said that we've had about 5 to 10x more success than the accelerator in second place. And so we're constantly trying to iterate on this, but really focusing on bringing benefits directly to the companies involved. We've got 27 teams that have already gone through and 18 teams that are currently in our batch. 75% of the companies have already raised funding, and over $25 million has been raised to date by the companies that have gone through our accelerator. So a lot of awesome success. A couple other quick resources I highly recommend you check out the Blockchain Acceleration Foundation. Full disclosure, I'm on the board of the Blockchain Acceleration Foundation, and the real emphasis is to get people into the space and provide them with resources. Similarly to Blockchain at Berkeley, but focusing on a global scale. And so what's really awesome is the team at Blockchain Acceleration Foundation has meetups that happen with industry speakers every couple of weeks. So it's a great way to understand and stay up to date with what's happening in the ecosystem. And then they also have funding opportunities for students specifically to be able to give them a little boost in the ecosystem. And although the Blockchain Acceleration Foundation focuses primarily on students, I still recommend you reach out to the founder, Cameron Dennis, as he's absolutely amazing, and he's always happy to provide resources to people that are trying to get into the space. And then another company that's also working on a similar goal is called the Blockchain Education Network. Yeah, Ben. And so definitely recommend you check them out as well. Ben is really more focused on students though, just as a heads up. And for those of you who are trying to tackle a deeper dive into the blockchain space, I definitely recommend you check out our developers decal. It's on our website. If you go to, I'll show you real quick. If you go to blockchain.berkeley.edu, then you can quickly navigate to our courses, be able to see all the courses that we offer both on campus and online, including our edX course, which has touched over 160,000 students. And then the Blockchain Fundamentals decal, which is what this course is based off of. And then sign up for our webinar. And then we've got our blockchain developers decal, which will take you through steps to building these smart contract applications yourself. And then, yeah, and that's kind of it for me. So thank you all for your time. Thank you to Fernando and Paulette again for giving me this platform to talk to all of you guys. Now I'd really love to open it up to any questions that you guys have about the ecosystem as a whole or any of the points that I've covered.
Well, thank you very much, Liam. I think we are on time. So actually we have some extra time to do the dynamics with the question. Before to start with this dynamic, I don't know if you want to answer some of the questions that are on the Q&A part, and then we can start with the dynamic together with Eloisa and Dulce and Paulette. So I don't know if you want to choose from 3 to 4 questions that are already in the Q&A.
Yeah, so I'm looking at the chat now, and I think I'm up to date on all the questions.
Okay.
Unless there's somewhere that I'm not looking. Oh, there's a separate Q&A.
Exactly.
I see. Okay. Sorry, guys. I didn't realize that this was happening throughout. Yeah, let me pick out a few here. All right. So, what are your comments on the fact that most of the mining power is allocated in or located in China? Do you see it as a problem for the Bitcoin blockchain? Yes. I think any form of centralization of mining is problematic, and so being really mindful of kind of how we continue to distribute mining across our ecosystem is really important. And so that's why I encourage all of you guys to run your own mining rig and contribute to the space to ensure that no one geographic location or no one entity has too much power. What is your opinion of the use of blockchain in traditional sectors such as finance and agriculture? Kind of broad question, and I think I touched on some of it, but it's really, there's so many applications, you know, and specifically talking about like the supply chain example with Walmart, I think is a great illusion of the examples that have happened successfully. Two-part question. What is your opinion on DeFi projects and what do you think of Sushi's latest trend that ended with Nomi's exit? Yeah, I won't go too much into depth on DeFi, but the DeFi space is really diverse, as I mentioned. Sushi is a token that was most recently popular, and as Juan mentions, the founder of it withdrew all of his money and left the ecosystem, which became problematic. So my biggest recommendation for all of you is just to be smart. Take things slow, do your due diligence, not invest any more money than you're willing to lose. Because at the end of the day, we're all trying to learn during these times. And so there's a lot to kind of process and take in, and mistakes do happen because everything's built by humans. Could Ripple-based overseas transfers avoid the threat of any government taxing these transactions? Potentially, if you stick to their if you stick to their centralized or decentralized solutions. So if you're working with XRP, the currency, directly, then yes. But if you're working with some of their solutions like on-demand liquidity and RippleNet, which are built with compliance in mind, then you will still have to be accountable for taxes. But I always recommend you pay your taxes because the tax man will always come after you. Then let me just see if there's one question that I didn't touch on. All right, here's a good one. What do you think will be the impact of blockchain technology and the impact of education? And how do I think about version 3.0 of Ethereum in the evolution of proof of stake? Yeah, so, you know, at the end of the day, education's important. I really applaud, you know, Fernando and Paulette and everyone else who's been able to give these lectures throughout the series because they're taking their time out of their day to help bring you up to speed. And that's the most important contribution that any one person can make to this space, is just by spreading good and strong information. And so what I really see in the space of education is more and more educational institutions adopting and integrating blockchain into their classes. We've been lucky that Berkeley has been a little bit slow, but they're making good progress now in integrating it into more and more of their classes. And so one example of that is even one of my housemates is a pre-med student studying, you know, medicine and biology. And even during one of his classes, the professor asked the students, hey, does anyone know what blockchain is and its potential applications for our industry? So just asking ourselves a lot of those questions. And in regards to, you know, Ethereum, I think any big changes to Ethereum or any protocol are a long way off. So don't get your hopes up. But I'll turn it back to Fernando, and I'll work on answering the rest of the questions by typing them out.
Well, thank you, Liam, and thank you for all amazing. I mean, you can resume the whole 4 Saturdays in 1.5 hours. So